Hello, welcome back to SQL learning session. Today we'll be talking about subqueries from database for developers. Let me start the setup, the prerequisite SQL for this lesson. In this lesson, there are around 14 sections, and starting with the introduction, inline views, nested subqueries, correlated, non-correlated, not in versus non-exist, scalar subqueries, common table expressions, CTE reusable subqueries, literal SQL, and testing subqueries. Starting with the introduction. Let's start with the introduction. This tutorial shows how to write subqueries. It uses bricks and color tables. Let's run these two queries to see what this table contains. There are two columns for brick table. There are 9 rows for brick table and 2 columns. And there are 6 rows for colors table and 2 columns. The tutorial makes heavy use of group by. If you are not familiar with a group by, then you have to do some refresher course for that. Next, we'll do inline views. What is an inline view? Inline view replaces a table in from clause of a query. In the query, the select from bricks is an inline view. Here's the example. Here, the select from bricks, this is inline view. This replaces the table for the select from in the outer query. Use inline view to calculate intermediate result set. For example, you can count the number of bricks you have for each color using this inline view. This is intermediate step. You are not directly sourcing from the source table, but you are using sourcing from intermediate table, where it processes the source table and gives the result you want. Here, this brick table is in process to count the number of records for each color from a color table. Number of bricks for each color from the color table. You can then join the result of this to a colors table. This allows you to find out which color you have fewer bricks than the minimum needed to find colors. Here, what we are doing, can you tell me? We are, first of all, we have two tables. One is bricks table and one is colors table. We are getting the number of bricks by color from bricks table and then comparing that to a colors table C to produce those rows from the bricks table that have less than minimum required bricks. And this will show you how. Here, green has a less than minimum required bricks. Minimum required is 3, but what we have here is 2. Now let's try an example. For here, in this exercise, we need to complete the query below using an inline view to find a minimum maximum brick ID for each color brick. Here, we need to select minimum brick ID, max brick ID, from bricks, and for each color. Therefore, the brick should have color in it. Color, then group by color. This should give the result we need. Yeah, we have for each color we have minimum brick ID and maximum brick ID, and that's what we are looking for. Next is nested queries, nested subqueries. Nested subqueries go in your where clause. The query filter rows in a parent table. There are two kinds of nested subqueries. One is correlated and one is uncorrelated. Now, who is talking about uncorrelated nested subquery, which goes into the where clause? Let me show you one. Can you tell me what does it do? This query looks at the table colors and gives those rows where if color name exists in the subquery from bricks. If there is a color name exists in a subquery from bricks, then it will give the record row from the colors table. That's what it does. There's another way to do the same query using exist. Let me show you. Here, this is something similar with what we have earlier. The only difference is that it uses exist function instead of in. What does it? What does the exist function do? Exist function works in a such way that what does the exist function do? Can you tell me? Exist function works in a way that when you when the subquery produces at least one result, one row, then the outer query will produce a result for that particular row. Meaning the query is satisfied if the subquery produces at least one row, then outer query will run. The outer query will run accordingly. Now you can also filter a subquery also. Let me show you how to filter a subquery. Here we have a subquery select B color from bricks where brick ID is less than 5. This is a subquery and you are filtering using where class here. And this is a this is the uncorrelated query. This is the uncorrelated query where you are searching for a color name in a subquery, and if the color name exists, then you are uh, presenting a row from the outer parent table. You can also do similar thing with the bricks using exist, where you do not care about what the subquery produces, but if the row exists for a particular condition, then you present the row from the parent table. As I said earlier, there's a correlated uncorrelated subqueries, and that's the next section is related to. A subquery is correlated when it joins to a table from a parent table. If you don't, then it's uncorrelated. This is the difference between in and exist. Exist joins a row from parent query as long as subquery find at least one row. So for uncorrelated exist, all the rows in the collar. Here, what happens is that if I get one row from bricks, then I produce all the rows from collars. Note when using exist, when you select in a subquery, doesn't matter because it's only checking the existing row that matches where clause if there is one. You can use select now or select one or select an actual column. This is because query means return all the colors in the table when there is at least one row in bricks. To find all colors in rows where at least one row in bricks of the same color, you must join a subquery. Normally, you need to correlate exist subqueries with the table in a parent. Now, moving on to not in versus not exist. You can do the reverse of in and exist by placing not in front of them. This returns all the rows from a parent which don't have a matching subquery. For example, to find all rows in colors without matching color in bricks, you can use not exist. This is what the query does. It returns all the rows from the colors without matching color in bricks using not exist. That means if the color don't exist in a subquery, then it will return it from the parent table. And here it says that yellow, purple, orange don't exist in the subquery. That is bricks. But there's an exception with the not in. Not in, you are not allowed to. Not in is a little bit different because when you run this query, it will not return anything. Why is that? It won't return anything because it's unknown. There's a color in bricks where one of the values is null, and when there's a logic called not in null, then it is unknown. Therefore, this query will not return anything. This is similar to this, where you are want the value of the not in is null. Now there's a solution to avoid this problem. For not condition to be true, you can do this by filtering the subquery for null. Here, you have the main query, and in the subquery, you're filtering for b color is not equal to null. And when you do this, it will return a result as we need. Now, let's try an example. Here, we need to complete a subquery to find all the rows in bricks with a color where color dot minimum bricks need equal to 2. How do you do this? Let me show you. We need to select c dot color name where C dot equal to 2. If we do this, then it should give us result what we need. And that's exactly what the case. Moving on to scalar subqueries. Can you tell me what a scalar subquery is? Scalar subqueries return one column and one row at most. You can replace a column in a select using a scalar subqueries. Now here's an example. Here we are getting rows from the colors, but on the column is a scalar subquery which is counting the number of bricks later part of color. Let me run this. You can see that for some of the bricks, the subquery is not returning in result because there is no brick associated with it. For example, for orange, there are no bricks, so that's why it's null. You can also zero out those null values using CoList function. Let me show you how. Here, those null values has been replaced by a zero in using CoList function. Another important thing to remember is that you see the scalar subquery is being joined with the parent table. If you don't do the join, then it will return error. Now, for experimentation, let's remove this and see what we get. The subquery is returning more than one row, and because of that, it is returning the error. So therefore, we need to join for a correct result. You can also use a subquery in the having clause for a condition. Here's an example. Here, we are querying from bricks and doing group by color, and there's a having condition where count is minimum is less than some value. This value is being generated using a subquery, scalar subquery, where it checks for a particular color from the color table and gets the minimum bricks needed, and that is used to filter the groups by color. You can use this similar to the way we did a query before, which was this query, where we use the join condition to filter the rows. And if you run these two, then you should get a similar result, where green was a color where that had a less than minimum required of bricks needed. Then moving on to section number 9, we're going to do an example where we're going to come to the scalar subquery below to find a minimum bricks needed for each color. Let's do this. We're going to do a scalar subquery for minimum bricks for each color. Minimum brick ID for each color. That is, we need to select minimum brick ID. Brick ID from bricks table where the color of the bricks, where color equal to color name. Let's see what happens. This is exactly what we need. This was showing is that for green the minimum brick ID is 4, for red it is 6, and so on. Next, we have common table expressions. Can you tell me what common table expression is? Common table expressions enable you to do name the subqueries, and you can refer to this like normal table anywhere in a query. These expressions go above the select statement. Here's an example where you have a common table expression with the brick color counts, where it counts the color of bricks, counts the bricks by its color, and then you are showing result in a select statement. Now we're gonna dig a little more into cities in the next section, section number 11. Because you access cities in the same way as a regular table, you can use it many times in a query. This can help if you want to use this query many times. For example, if you want to find which color you have more bricks of than minimum needed, and average bricks you need to have for each color. You need to group the bricks by color, then filter colors, filter table, color tables where when this count is greater than minimum bricks needed for color, and compute the mean of the count. You can do these by filtering message subquery and show the average of scalar subquery like this. Here are two things being done. First, we are computing the average. We are computing average for color. For each color, for we are counting number of bricks by color, and then we are computing the average bricks. That's one thing is being done here. Second thing, we are counting the number of bricks for color and checking whether it is greater than minimum bricks required. And if those are true, then it is showing you the color name. If you look closely, you will see that a group by color is appearing twice. This creates a maintenance issue in the long run, because if you modify one bricks, then you have to modify other also. Like if you join the bricks with some other table, then you have to join in a second place also. To do this, we can use a common table expression where we'll call the common logic once in the expression. That is here, it is using brick counts by brick. Now this brick count is being used in the scalar subquery where we are counting the bricks from brick counts and doing average on that. And also you are using the brick counts, same logic from brick counts, and doing putting that in the having clause, in the where clause. When you do this, If you join the bricks with some other table, then you have to modify only once. Cities are really powerful because Oracle data optimizes these queries if you access this query many times. Now, moving on to section 2 of Literal SQL. Literate programming is a common concept introduced by Donald Knuth. The idea is to write a code that makes sense if you write it like a book from start to finish. Simple queries follow this principle. For example, give me a book brick ID of all bricks that are red or blue, which is similar to this SQL statement. But subqueries break this flow. Now here's an example. If you want to find a bricks, you have less than average number of each color, then the step should go like this. Count the bricks by color, take the average of these counts, and return those rows where step 1 is less than step 2. Now, when you write the query without the common table expression, it goes something like this, where we are calculating the count by color at the last step of the SQL, then it should first step. This breaks the flow. To solve this issue, we can use the CTEs or common table expression, where the first step is to count the bricks by color. Secondly, taking the average of the bricks count. And thirdly, comparing the average with the count to get the result we need. Section 13, testing subqueries. Another big advantage of CTEs or common table expression is to make a query easier to test and debug. If you want to check that brick counts from previous query are correct, you can do the following. Here, you have these CTs here, common table expressions, and if you want to check whether the previous on the count one of the values from the on the subquery is correct, you can just query from that and check if it's correct. But if you do inline views, then it's a little bit harder to do this checking because you rip out that particular piece of SQL to do the checking. At last, section 14. We'll do being an example here. We need to complete the query to count the how many rows there are in the colors. How do you do this? We can do this by selecting from colors table, selecting count from colors table, and it should give the result we need. And that's exactly the result what we have. In the end, let me quickly summarize what we did today. We started with the inline views. We talked about nested subqueries. We talked about difference between correlated and uncorrelated subqueries, nested subqueries. We also talked about not in and not exist. Then we talked about scalar subqueries and common table expressions. And we dig deeper into the CTEs and how it's really useful in writing SQL. We talked about literate SQL and how it helps to write literate SQL using CTEs. And we talked about testing the subqueries. So that's all for today. I will see you next learning session. Thank you so much.